Hey guys, we are here with another hands-on video. In this video, we are going to bring up a lab containing the Kubernetes and a log aggregation monitoring system in it, and we will learn how exactly it works under the hood. So without any further ado, let's get into it. So first of all, what is the log monitoring system? Why do we need it? So imagine you currently have an application and a customer, a client. The client is sending requests to the application replies back, and everything goes well. Now imagine you're gonna have several clients sending the request to the application. All of them expect an answer, and all of a sudden some of the requests are being failed or just being responded with another response code. Now we need to understand what's going on in the system and why exactly that happens. What can we do in that case? So any developer that is developing an application probably would also implement a logging system in it. So whatever that is happening in the application will also be logged. If there is an error, the error should also be logged. So the first step would be just checking the logs generated by the application. So basically, we need log monitoring because it will extend our observability and help us to understand the system behavior better. And most importantly, it will enable us to proactively detect and fix bugs. But when we are talking about log monitoring and aggregation system, what exactly it is? In our scenario, we have multiple applications, each of which are connected to their own dedicated database based on the design we have, and each service is generating logs. So when we are talking about this system in scale, then there's going to be a challenge. How exactly is it possible for a human or SRE engineer to check the logs, all the logs basically simultaneously, and find what exactly is happening in the system in case that we are facing with an error? So in this kind of cases, we can send all the logs to a system, namely a log aggregation system. Then log aggregation system will just do the magic with the logs, store them, categorize them, index them, and finally provides you with the benefit of go through all the logs seamlessly or search for specific logs, for example, the error logs. So all in all, the log aggregation system is a system that enables us to search and filter all the logs easily. It will help us to understand what's happening in the system, in different components, and also it helps us to spot errors and issues way faster. There are so many log aggregation systems out there, but the most famous one are like Grafana Loki, Fluently, Datadog, and Logstash. But how exactly this log aggregation system works, and how can it just provide us with that kind of benefits? We will cover that through the scenario we will implement in this video. So in our scenario, we have multiple applications. Each application is creating logs. We have one database, the database as well is creating logs. And then we need to send them somehow to the log aggregation system. For that purpose, we use Kafka Cluster. But wait, what? Why Kafka Cluster? We will answer it shortly. And from the Kafka Cluster, we will send the logs to Grafana Loki. So what should happen is just like all the logs should be sent to the Kafka, and Kafka then will send all the logs to Grafana Loki, and Grafana Loki do the magic on top of the logs, index them, categorize them to whatever that is supposed to be happen on the logs, and finally store them in the storage backend configured to be used for Grafana Loki. There are different storage backends compatible with Grafana Loki, but what we are continuing with is GSS bucket, which is Google Cloud Storage, which is like Google Cloud Object Storage, better to say. And finally, send all the logs there. Then when you want to see the logs, it will just fetch them from the storage and so on and so forth. But the main question here is like, why do we need Kafka Cluster in between? Couldn't we just send all the logs directly to Loki? And the answer is yes, of course you could. But it's not the best practice for few reasons. One of them is like, what would happen if Grafana Loki for any reason goes down? If all the applications are configured to send the logs to Grafana Loki and Loki is done, that means for the time that Loki is not up and running, all the logs are being lost. The other benefit is and the other issue is like, imagine you have so many applications and all of them are under the load, generating so many logs simultaneously. Then all of them are responsible to send the logs to Grafana Loki. And because of the number of the applications and also the high pace of generating logs, that might hit the Grafana Loki rate limiter. Again, lose of logs, which is not intended at all. We should avoid that situation. And because of that, we are going to use Kafka Cluster. When we have a Kafka Cluster in between, even if Grafana Loki goes down, still all the logs are stored in the Kafka Cluster. As soon as Grafana Loki is up, it will continue consuming the logs and nothing will be lost. And also Kafka Cluster itself is like highly available cluster, so it won't easily go down. I mean, it's a reliable message queue. So all in all, this is the setup that we are going to implement in this video. And now let's focus a bit more on the Grafana Loki itself. How exactly it just deals with the logs. Let's talk about the simplified scenario of us. So we have one application, one database. Those are sending logs to the Kafka cluster, and each application is sending logs to a specific topic. For example, we can configure the log shipment in a way that all the logs for the application are being sent to a topic, namely application in Kafka. And all the logs for the database services are being sent to the topic, namely database in Kafka. Then we need a consumer. We will use Grafana Alloy, which is responsible to consume all those logs from Kafka, and then apply some logic on top of that. For example, Alloy will be configured in a way that it adds specific label, let's say job app, to all the logs, all the messages basically, that are stored in the topic application, and add the label job equals db to all the messages stored in topic databases. Why do we need that? Because then we are able to configure the distributor or Grafana Loki in general to deal with different labels differently. So for example, we might want to keep the logs for the application for a longer time, but the logs for the database for a short time. So we can have different retention policies for different labels. And distributor is also responsible to route the logs with a specific label to the proper ingester. Then ingester will just ingest the logs, index them, store them, so on and so forth, and make it ready to be used by the user. So all in all, this is what is going on in Grafana Loki under the hood in general. And now that we know what we are going to implement, let's bring it up. So first of all, I would like to just remind that one more time that all the labs that we are working with is already stored in the public GitHub repository, Grafana DevOps land, and then you shall have a different labs there with proper README files. So if you go through the README file, you can replicate whatever that is going on in this video and just have it set up on your own lab and gain experience working with that. So once again, what we are going to do is all in this GitHub repository. As I already have that in my local machine, let me just make sure it's up to date. Very good. So what we are going to do is simply going to the log monitoring directory. We can simply go through the README file, which I will do very quickly. I try not to just take your time, just going through all the details again and again, but instead what I'm gonna do is like bring up the infrastructure very quickly. If you are not familiar with the setup of these videos, you can just simply check the previous videos as well. But in general, we are using the kind tool to bring up the Kubernetes cluster. and we will use ArgoCD to deploy all of our deployments. And this is how we go through all the labs. So the first step again is just like bringing up the infrastructure very quickly. You have a directory in the log monitoring, which is like infrastructure. Let's go through it. And then let's bring up the kind cluster. If you check the content of it, just like the previous videos, it's a very simple kind Kubernetes cluster with 2 workers. So let's have it created. Cool. Now that we have the Kubernetes cluster up and running, it's time to install ArgoCD. We can use helm install command to do that. So let's make it. Okay, create MS ArgoCD first and then install it. Cool. We have the ArgoCD up and running. It's already installed. So let's open up a shell and continue working with that. The first step and the next step is just like going to the ArgoCD and installing the required application. Before that, let me show you what's going on. We have a directory in the application. All the required component that we already discussed about in the introduction is already here. We need Grafana because it's going to be integrated with Loki, and then we can see the logs and just visualize them, create the alerts for them, and so on and so forth. We need the Kafka Cluster, which itself will be managed by the string operator. We also need Loki. So all of them are actually, let's say, ArgoCD applications created here. And we have another directory named log generator. If you want to see the log generator code, it's already in the log generator directory up right here. It's a very good, simple Go application. This is responsible to generate random logs and send them to the Kafka cluster. The Kafka cluster address will be passed via environment variable. You can go through it, but it's already the code is already here. The Docker file is also here. I also created the Docker image and sent them to the public Docker Hub repository. So what I'm gonna do in the log generator is just creating a deployment out of the image created, and then it will be come up and start generating logs, sending them to Kafka. So if you pass this specific directory to ArgoCD and then set it as like a root app, ArgoCD will iterate through it and span the whole components that you need. So this is what we are going to do right now. So first of all, let's start off by getting the credentials for ArgoCD. So running this command, I would not continue with the shell of the VS Code. Instead, I will do this like, what happened? I will do this like this. So this is the password. Then I will just rename it to ArgoCD. And then what I'm gonna do is like forward, because I didn't set up any kind of ingress. We don't need it actually. So this command will just forward all the requests or just create a TCP connection between the pod, between the service that you mentioned here and specific port on your local host. So let's see, it's already created. Let's go here. So if I go to port 8080 plus, if I'm not mistaken, you shall safely pass through it because it's the lab, just like in your local host. The username all the time is admin and password is whatever we got here from the previous command, and then we shall log in. Then we have to go to the setting and add the repository. Why? Because all the application folder that I already talked about is in that Git repository. So let's have it added. I just need to grab the URL, HTTPS, of course. Don't want to go through the SSH keys. HTTPS, the name is like for DevOps Zen for sure. Only one project we have for the time being, and that's it. Okay, it's success. So what we are going to do next is just like by simply creating a new ArgoCD application and add the root directory we mentioned 2 minutes ago here. So I would call it as root dash application, naming like that, and then let's have it automatic sync, and then of course create all the required namespaces. Yeah, this repository, but what is the path? So the path is like lab dash log dash monitoring slash just don't want to make a mistake. Let me check. Log dash monitoring, and then we have applications, and inside application is everything. So applications. So it's going to be hosted the same, and don't remember to enable directory recursive as as check, because that makes it as like a root application. I thread through all the directories and then deploy the things correspondingly. So that it is. Let's see if we have any error. We have error lab dash. Okay, I think again typo. So where is it? What happened? Log dash monitoring and then create. Okay, the root application created, and if we go to the root application, we shall see all the components here, right? So Kafka namespace, log generator, Kafka UI, Grafana, Loki, and so on and so forth. So basically, whatever that we need to have in our stack to start working with the log management system. I see an error here. So if you go to the streamz, for one thing, you shall see the components are coming up. After that, the Kafka cluster would up, and so on and so forth. If in any case you face with a situation that the sync failed, just stop the sync, terminate the syncing, and then manually sync the streamz first. I didn't use ArgoCD sync waves, but it's important that the streamz should come first, because this is the initiator. After that, the Kafka cluster can come up, and so on and so forth. So that's also something to mention, and from now on we just need to wait. I just resynced it, and you can see now Kafka UI is coming up, and the log generator is also coming up, and more importantly the Kafka cluster itself is coming up. So the zookeeper, and then we shall have the Kafka up and running as well. It's gonna be a bit of time consuming, specifically because it's gonna download so many images. So it depends on your internet connection, you shall wait a bit. While it's actually coming up, we can use this time to cover the back-end storage and then going through the Loki configuration. So let's do it right now. If you go through the Loki directory, you shall see two components here, Loki and Alloy. So if you check the Loki application, you shall see the Alloy Helm chart as well is being deployed under the same application. So the Alloy configuration is already here. So in the Alloy configuration, we already mentioned that, hey, you should connect to a specific Kafka that can be found here. If you don't know the namings and so on and so forth, you can simply check the other video we have for bringing up a Kafka cluster using a string. But basically, this is the address of the service attached to the Kafka that is brought up by the string. So we mentioned already that, hey, as a matter of the brokers, fetch everything. So all the brokers are here. If you want to go with a specific broker, you shall just name it here, or if you want to just take, with the regex, you can also do that. For the topic, for the labels, we already mentioned that you should add one component, Loki source Kafka, for sure, and then forward whatever that you fetched from the Kafka to this particular receiver. We will define it a bit later, but it already knows that whatever that is being fetched via this rule should be sent to this receiver. So we mentioned that using common timestamp, it's gonna be helpful probably for, debug purposes at the end of the day. And we mentioned that relabel it with the rules and group ID. So the group ID is basically like the consumer group that will be created in the Kafka. In case that you have more than one alloy, all of them will be joined to this particular consumer group. So the case that, one log should be fetched with two different alloy it's going to be avoided. So that's the reason we create the consumer group. So we shall have many alloy instances for the sake of just, splitting up the receiving logs from Kafka a bit. But none of them could just get like repetitive logs. One log too many times. So that's about the group ID. And then we will also define a Loki relabel with the name of Kafka. And we say all of them with the name of Kafka should be, again, forward to this receiver. We also define another rule for this relabeling and target. Hey, whatever you see as a matter of topic name in the metadata, create a label namely topic and put it in this label. So that way you can basically distinguish that in the Loki. We shall see it in action. And finally, Loki write local, which is being used here. Loki write local. So the endpoint is the endpoint of the Loki. So all of the logs will be pushed to the Loki via the service attached to the Loki. We shall see it again, but you're using hello chart. So this is the service address. If they are all in the same cluster, remember that, else you have to just address it in another way. But if all of them are actually with the same cluster, this is the service address and all of the logs going to be pushed to Loki. Remember, we also assign the tenant ID because our setup is going to be multi-tenant. As a matter of the multi-tenancy in Loki, that means that you can treat different tenants or differently. So we create only one tenant at the moment, namely tenant global, which is supposed to hold all the logs. Later, when we check the configuration for the Loki, you shall perfectly understand what's the meaning of this tenant global and why do we just address it here. Let's now go to the configuration of the Loki itself. Quickly go through it. We will choose to continue with the deployment method of simple scalable. We have three different methods of deploying Loki. One of them is like a binary, the other one is like simple scalable. In simple scalable, you have better decoupling in the system. So basically, you will come with like writers, readers, ingesters, and so on and so forth, different components, and then you can just scale them differently. So if you have large volume of just logs receiving and arriving to Loki, you will simply increase the number of writers and then you can handle the situation and so on and so forth. So this is actually very good architecture for mid-level volume of let's say productionized amount of log. Here we assign out enabled as true. So this particular configuration is absolutely related to multi-tenancy. So by adding this, we basically enabled the multi-tenancy in Loki, and then we can just treat each tenant differently. It provides us with more flexibility. And in the common config, nothing specific to mention, but about the storage. So as mentioned, Loki can just handle different kind of backend storage. We will continue with the GCS. We already mentioned that the type of the storage is GCS, the bucket name for chunks, ruler, and admin. All of them are Rafi-lab-log-monitoring. We haven't created that part yet, but we will do it soon. So remember that this is the name of the bucket we have. We will continue with the TSTB storage. It's fast, it's efficient, and the compaction ratio is very good. Again, the TSTB should also store in the GCS. And yeah, the ingestion rate limit and so on and so forth, you can just check the documentation. It's a very high value suitable for production, but in general you can define what would be your rate limit. And yeah, for the compactor, we already mentioned that this is another important part. We already mentioned that every 10 minutes indexes should be compact, and what exactly it does is basically every 10 minutes it will go through all the chunks index actually it has, and then try to combine all the chunks that are combined that can be combined. That way you will at the end of the day come up with bigger chunks, but it will increase this and the speed of ingesting the logs when you are trying to access the logs. We also said that the let request store GCS. So basically, after retention policy that we mentioned here, it will also delete the old logs from Google Bucket. So I mean, your object storage would not just increase, the size would not increase indefinitely. And then retention period of like 30 days is being set here, and the ingestion rate limit again, and burst rate limit. So these are the configuration of the Loki for our scenario at the moment. We also saw the configuration of Alloy, and now it's time to create the bucket. So Loki is actually able to connect to the bucket. So let's make it very quickly as well. So to create the bucket, you have to basically go to console.google.com. If cloud.google.com, if you don't have account, you can simply create it. It also provides you with ability here. But anyway, I will just use one of the projects I have, maybe even this one, and go to buckets. And here I will create a new bucket. The name of the bucket should definitely be the one that we have here. I will just copy and paste it just to avoid any kind of typo. Cool. No specific label. I mean, yeah, I mean, let's I would say multi-region. So let's continue with multi-region, and then yeah, everything is standard. We don't need to really play with the configuration here. If you want to implement it in production, you go with your own choices, including like having it faster and so on and so forth, or I mean more resilient. But for the purpose of this video, we will continue with the normal configuration. Public access will be prevented, which actually is the thing we want. So confirm. Very well. So the bucket is already created. Now that the bucket is created, we have to also provide a way for the Loki to access this one, because this is a private bucket, right? This is not something public and no one can access it but Loki. So for that purpose, what we are going to do is like going to IAM section, and then create a service account. So going to the service account section. I already created this one in previous try, but I'm gonna just delete it right away. Just delete it simply. And then I will create a new service account. So the service account name would be like Kafka monitoring -lab, for example. and then this one, which I should definitely remove because it's already exposed in the video, but anyway. So this one, and then I don't want to assign any kind of permission to it right away. So what I'm gonna do is just like creating the service account, and then I will also create a key for it. So if I go to the service account, I go to the keys section, I will add a key, create a new key, format of JSON, looks good. Let's have it downloaded somewhere good. So if we go to this one, I will just rename it to what exactly? I will rename it to, I mean, doesn't really matter. Let's have it for this time, maybe log dash monitoring. Cool. So now that we have the key created for this service account, if we provide the key to the Loki using this key, Loki will gain all the permission that this service account has. So there is only one missing part here, and that is like providing enough of permission for this service account to read and write to that Google bucket, right? So let's do it as well very quickly. We can do it in different ways, but what I'm gonna do is just like going to the bucket again, because I want to just provide enough of permission for this particular bucket. We shall go to the permission, and inside the permission, I will grant access to, what was the name of the service account? It was like log dash monitoring dash what. So okay, I mean, I need to double check it again. So I will again go to IAM. So this is the service account. Copy it, going back to bucket here, and then permission, and then grant access for this specific principal. What's the role? So it should be like storage admin I will assign it to, but in production again you can just do it whatever you want. So object is storage admin, of course. Save. Cool. Now let's go back to the code we have. So first of all, let's see what do we have right now deployed by ArgoCD. K get ns. We first go to Loki, K and Kubernetes Loki, K get pew. I don't expect Loki to be up and running because we already saw that it's already configured to be connected to the Google bucket, but we just created the Google bucket, and we still have not provided the service account key to Loki, so it should be failed. But let's see. Yeah, as you can see, some of them are pending, some of them in container creating, and so on and so forth. Let's describe, for example, this one. Describe PO this one, probably lacking the secret, but let's see. Volume bonding operation could not be fulfilled exactly. The object has been modified, plus, yeah. So the secret we have to create. Just to make sure, I will again check another one. So for example, this one, or actually describe here this one. Volume on setup, Loki dash secret. Exactly. So basically it's waiting for creation of the secret. So now using that service account that we download and a service account key that we downloaded, we have to create a secret containing the content of the service account key, and then Loki can come up. But first, let's go back to the configuration of Loki to make sure what is the service account's name. So it's already exposed as GCP service account.json, and yeah, it also is mounted as a Loki secrets. It will just read the Loki dash secrets with the key GCP service accounts. So what I gonna do? What I gonna do is just like I will yeah. So ls element it was yeah, it was this. So instead of this one, I will envy this one to whatever name it is. So yeah, cool. And then I will create a secret out of it. Create secret, generic. The name of the secret again, it was like Loki dash secret. From the file, it's not in the downloads, it's in my home directory, and that's it. So okay, get secret, yeah, it's already created, and I expect some of the pods should start coming up very soon. Let's see a bit. To speed up the situation, what I'm gonna do is just like, okay, I wanted to delete one of these, so basically it will try to recreate it, and this time it has access to the secrets and so on and so forth. So, but there is no need for that anymore. So backend is coming up. k-like-f this one. Cool. Okay, get PO. We also need some of the right components to be up. Like-f this one. Yeah, it's also up and running with no error. We have Alloy up and running. We have Canary. One of the backend at least very good. We have one of the writes up and running. We need to wait a bit. Yeah, we have it. And as well the read one. Where is the read component? Yeah, we have the read. Okay, so we are good with the Loki. Let's go to Kafka. Kafka is up and running. Very good. What I gonna do is like connect to the Kafka very quickly and create a topic. To that, for that purpose, I already created as well a Kafka UI. So let's forward the service of it. So forward this time, not Grafana. So get PO, we already have it. Okay, get SVC. So we have this service. Okay, so UI. I will port forward the service to port 9191. Very good. And if we check it right now, cool. The Kafka clusters are up and running. The application I created is not configured to create the topic automatically, so the topic should be there. For that purpose, I will add the topic, namely maybe logs, something like that, with minimum number of partition. I mean, that's also very important. Number of partition. Please remember, if you care about receiving all the logs in order, you should definitely go with the number of partition 1. If you go with more than that, there is no guarantee that Kafka would just deliver the logs in order. So I will create the topic now. The topic is here. Now let's check out the Now let's check out the kget-ns log generator. Kubernetes this one, and then kget-po, and then check the logs, logs-f this one. Yeah, until we created the topic, it was like unknown topic or partition, because the topic was not there and application wasn't actually configured to create the topic automatically, but now it's actually sending the logs right to the Kafka. These are random logs with different log levels, but let's see if we receive anything. So if we go to messages, we shall see all the logs here as well. So what is now expected is Grafana Alloy component should be connected to this Kafka service and create the consumer group, and then start ingesting these logs, send them to Loki. Let's check it. So for the consumers, we already have consumer group Alloy first, which is created by Alloy, and that means basically it doesn't have any kind of lag, so that means basically all the logs are being consumed. So at this moment, I think we have everything up and running. Okay, get PO, Kubernetes Loki again. Okay, get PO, just to make sure that we don't have any issue with the service account and so on and so forth. So what I expect is, if I go to the Google bucket right now, I shall see some files and index there, because Loki is receiving the logs from Alloy. It's responsible to, of course, in batch after a while, send them to the Google storage, Google bucket storage, and then I have to, I should be able to see the logs there. So let's go there. So if we go to the overview, if you go to bucket, if you go to our bucket, we already see that the index directory is created, right? And that basically means that Loki has access to this bucket for reading and writing. So we are good to go. The only remaining part is like, we know that Loki is working, we know that Loki is now receiving the logs, we know that the components are working as expected, but how can we see, how can we actually search through the logs easily? And how can we see the logs and then, just create a visualization of them, create alerts for them, and so on and so forth. For that purpose, another component in the application directory was Grafana. So if you check the Grafana, get PO, okay, get SVC, I will also expose the service for it. So forward Grafana port 5050 is good. If I go there, this one, maybe, where is that? Okay. I have this one, admin, come on, admin, but I don't know the password, so easily I can check it out. Okay, get secret, secret Grafana -OYAM. So what do we have here? We have user, and then we have password. So I can use this password. Echo this one, 5base64-d to get the coded format, and this is the password. So I shall copy it. I will just paste it here, and we are in. Cool. So for that purpose, you have to add a new connection between Grafana and the Loki, so it can just start visualizing the logs in the Loki. I will go to the add new connection. I will search for type Loki, and then I need to go away. I need to actually add a new data source. Loki, the name is good, but I need to provide the address for it. So the address of the Loki is actually the service name, because they are all in the same cluster. If you are going to multi-cluster setup and so on and so forth, you will provide the ingress address, or whatever that you need to. But at the moment, these are all in our lab in the same cluster, so this name is actually the service name for Loki. And then in the authentication, we didn't have any kind of authentication, but we enabled the multi-tenancy. So the most important part right now is just like addressing a specific header. If you check the documentation for Loki multi-tenancy, you shall find it, but in general, if you enable the multi-tenancy, you also need to specify which tenant this connection should be established for. And for that purpose, we have to add new. So we need to go to the HTTP headers, and then we need to add, like, let's search for it. I mean, Loki multi-tenancy error. If we go to segmentation, so which header it should be? Yeah, this particular header should be sent. So I will add this one here, and the value is the name of the tenant you created. We can easily check it to maybe Grafana Alloy, and the tenant is like tenant-global, right? So I will set it. Let's check the connection. Yeah, the data source is connected. What would happen if you just remove this one, right? Then if you check the connection, it fails. It's not because the Loki is not up and running. It's because you already enforced Loki to only answer in the multi-tenant form, but you didn't provide any kind of scope for it. So we definitely need to add this scope again. I can never remember the header. So we are good to go. And now if we go to the Explorer section and check for Loki, you shall see the labels already, the component, service name, and topic. And in the topic, you shall see the topic named logs, which corresponds to the topic you have there created. And then if I run all the logs our last hour, you shall see all the logs here. If you go through it, you shall see then the level and so on and so forth. Remember that it's a very simple logs. So basically in production, you're gonna have, more complicated logs, probably in the JSON format. It totally depends on the setup. But in general, that was it. From this moment on, you can also visualize the logs using different panels in Grafana, create an alert for it. For example, as soon as you receive an error or warning or so on and so forth, you shall be notified using alerting system. But this is in general the system. As you can see, the logs are live. They are coming to the system. They first go to the Kafka and then come back here. So that was all about this on-hand session. We already created our lab, so you have the chance to gain all the experience working with this system, playing with it before going to production. If you find this video useful, please do not forget to like it and subscribe it. That's a great help for the channel growth, and it's actually a very good motivation for me as well to continue creating this kind of content. I hope you found the video well, and also I would appreciate if you could also share the links to your friends or whoever you want, whoever you think might also find this video useful. See you soon on another video. Thank you. Goodbye.